Day 3, Wednesday. Today's goal is to describe characteristics of weather, focusing on wind, humidity, and precipitation. Complete pages 6 through 11 of the packet, where we will focus on characteristics of weather. When you finish this section of the packet and watching this video, here are some extra resources. What causes wind, humidity, and precipitation. Let's get started. Wind is the movement of air. Wind forms because of differences in temperature and atmospheric pressure between nearby regions. Wind tends to blow from areas of high pressure, where it's colder, to areas of low pressure, where it's warmer. Figure 5 shows wind, which is caused by air flowing from high pressure to low pressure. When we think about pressure, we can think about this image. Air molecules generally move from areas of high pressure to low pressure, where there's more space. We can think about this with the picture of density. The picture on the left shows an area of high density, lots of particles packed into one amount of space. The picture on the right shows an area of low density, where there's more room for these particles to move around. Just as human beings like areas with space where they can move, air particles behave in a similar way. In the upper atmosphere, strong, fast winds called jet streams occur at altitudes of 8 to 15 kilometers, or 5 to 9 miles, above Earth. They usually blow from about 129 to 225 kilometers per hour, or 80 to 140 miles per hour. But they can reach more than 443 kilometers per hour, or 275 miles per hour. These upper atmosphere winds help push weather systems around the globe. Figure 6 shows the polar jet stream and the subtropical jet stream. This GIF shows an example of the jet stream in action. Of course, it's been sped up, but you can see the patterns as it moves through Earth's atmosphere. Wind can also be influenced by human activity. Chicago, Illinois is nicknamed the Windy City. After the Great Chicago Fire of 1871 destroyed the city, city planners rebuilt it using a grid system. This created wind tunnels. Winds are forced into narrow channels, picking up speed and strength. The Windy City is a result of natural and man-made winds. Figure 7 shows 1940s Chicago. Let's explore the average wind conditions in Tulsa during the month of April. Figure 8 shows average wind speed in April. Our y-axis shows wind speed in meters per second. The x-axis shows date. We can use the grid system to match our date with the wind speed. For example, on April 1st, the average wind speed was 5.4 meters per second. Figure 9, wind direction in April. This graph shows the percent of wind according to direction. The y-axis shows percent of wind speed. The x-axis again shows date. This graph is color-coded to show the 4 directions of wind: blue, north; green, east; red, south; and brown, west. For example, if we look at March 1st, over 40% of wind speed was south. Let's check for understanding. 17. How does wind form? 18. How do weather systems move around Earth? 19. What 2 factors influence wind? How? 20. In Figure 8, what is the average wind speed in meters per second on April 8th? 21. From March to April to May, what is the trend of wind speed in Tulsa? Remember, trend means change. 22. In Figure 9, which direction is most of the wind coming from during April? What percentage? 23. Review the temperature trends for Tulsa in Figure 1. What might be the relationship between April temperature trends and April wind directions in Figure 9? Humidity. Humidity refers to the amount of water vapor in the air. Water vapor is a gas in the atmosphere that helps make clouds, rain, or snow. Humidity is usually expressed as relative humidity, or the percentage of the maximum amount of water air can hold at a given temperature. Cool air holds less water than warm air. If you've seen The Incredibles, Frozone uses the humidity or moisture in the air to make his ice. Let's explore the humidity comfort levels in April for the city of Tulsa. Figure 10. Humidity comfort levels in Tulsa. The y-axis shows us the percent humidity, relative humidity. Again, the x-axis shows the date. Remember, we can use the grid on this graph to match a date with a percentage of humidity. The graph is color-coded to show us different levels of humidity and how it feels. For example, the light gray or light blue indicates dry. Green is a comfortable amount of humidity. Yellow indicates humid. Orange is muggy, while red is oppressive or extremely humid. Let's check for understanding. 24. Define humidity. 25. What forms as humidity increases? 26. In Figure 10, what is the trend or change for humidity in Tulsa from March to May? 27. In Figure 10, what comfort levels of humidity are present in April? 28. Examine Figure 1, Figure 9, and Figure 10. What relationships might temperature and wind and humidity have with each other? Justify your answer with data from figures. Precipitation. At a relative humidity of 100%, air is said to be saturated, meaning the air cannot hold any more water vapor. Excess water vapor will fall as precipitation, rain, hail, or snow. Clouds and precipitation occur when air cools below its saturation point. This usually happens when warm, humid air cools as it rises. The most humid places on Earth are islands near the equator. Singapore, for instance, is humid year-round. The warm air is continually saturated with water from the Indian Ocean. This picture shows where Singapore is located. Let's explore the probability of precipitation in April for the city of Tulsa. Figure 11. Probability of precipitation in April. The y-axis shows the probability of precipitation, and the x-axis shows the date. Notice, we can use our grid to match a date with the probability of precipitation. Let's check for understanding. 29. What is precipitation? 30. What does it mean when the air is saturated? 31. When does precipitation occur? What type of pressure system is associated with this process? 32. In Figure 11, what is the trend or change for precipitation during the month of April? 33. In Figure 11, what is the probability of precipitation on April 15th? 34. Review Figure 10 and Figure 11. What is one possible relationship between humidity and precipitation? Justify your answer with data from the figures. Some things to think about. Read more about the Chicago Fire of 1871. Watch this clip from The Incredibles. How is the humidity important? Can wind and humidity be related? If so, how?